it's going to clip on. I say that all the time. Do. Oh my gosh. See, I think I got that lined up right. All right. Hey, hello. Happy Saturday. So doing more code challenges here, and then I'll be back later to do a bit of project work on QIT and maybe some Beam too. So gonna have a big programming full day here. Also, real quick, there are cool bandanas out there that exist. We're about to have or some counties near me are having like face mask orders, and so I've been looking at nerdy nerdy bandanas. So anyway, the shipping is awful. It's gonna get here in May, so anyway, on to happier things. Diameter of a binary tree. Okay, so given a binary tree, you need to compute the length of the diameter of the tree. The diameter of the tree is the length of the longest path between any two nodes in the tree. This path may or may not pass through the root. Okay, so in this case, they say return 3, which is the length of the path of 4, 2, 1, 3, or 5, 2, 1, 3. So that's interesting. I've never seen anything with like the diameter of a search tree before. Also, it's strange to me that the the result here is 3 when there are 4 elements. So I don't know, that's weird. Note the length of path between two nodes is represented by the numbers of edges between them. Okay, so we're counting the edges 1, 2, 3. Okay. So my first inclination is basically a depth first search. So, in that case, or depth first traversal, I should say. So we'll go down, go back up, go here, go here, go here, go here. As we're finding the distance, the biggest distance between two nodes. Now we do know this is a binary tree, and binary trees have special rules. That's not true. It doesn't say binary search tree, it's just a binary tree. So all it means is that each node only has 2 children. This one just happens to be arranged like a binary search tree. Oh, no, that's not true. Oh my gosh, okay. 2 is greater than 1, 3 is also greater than 1, so this is obviously not a binary search tree. Okay, so this is an interesting problem. I don't think the solution's going to end up being complicated, but I'm also not sure how to do it. I mean, I can kind of reason about constructing kind of chains of how we've traveled. So if we imagine kind of pushing this stuff on a stack as we do a depth first traversal, I would start with 1, 2, 4, 5, and then 3. But that does not mean that we've got a 1, 2, 3, 4 size traversal, because 2 and 4, or sorry, 4 and 5 have the same parent. So I know that I can collapse those, but what is throwing me off is that 2 and 3 also have the same parent, but I'm keeping them. So I'm trying to figure out what the difference is between those two use cases. Like, how do I know that 1 is okay, The only thing special about it is that it was the root. And they do call out here that the path may or may not pass through the root. Which is interesting. I guess I can imagine a use case like a tree that looked like 1, 2, 3, 4, 5, 6, sure. And we'll do one more for good measure. So in this case, the diameter would be 6, 5, 3, 2, 4, 7, or 1, 2, 3, 4, 5 edges. It would not pass through the note, through the root. Alright, so what if I loop through this one in depth first traversal? I'll push 6, 5, 3, 2, 4, 7, and then I would start backtracking. So I wouldn't count the 4 again. I wouldn't count. Oh, you know, I didn't do that right. I did do that right. If I did a depth first traversal, then my strand would be 6, 5, 3, 2, 4, 7, and then I wouldn't count anymore because I'm backtracking at this point. This is to say, back to 4, back to 2, so it would be a 1, but 1 isn't in my chain, and I know that because I backtracked to get there. Is that the secret? Let's try their example again. So we're doing the 1, 2, 4, 5, 3. If I did a depth first traversal on that and said we've got 4, we've got 2, we go down to 5. So there's one span. So when I backtrack, I could lob that off and say, okay, there's one span of 3 that I've seen. But now I'm backtracking. So let's erase that 5. We'll go up to 1, and we'll go down to 3. And then I'm done. I've done the entire traversal, and I could say, hey, that's my longest span. So that's good. Okay. I think that might be the solution there. So to kind of pseudocode that out, what we're talking about doing is depth first traversal. And then on backtrack, save the current. I called it a strand. I don't know any official term for that. And then at the end of the algorithm, we'll basically say return the length of the strand, the longest strand, minus 1. And the thing is, I actually don't need to keep all the strands around. I can always just keep the longest. And the current. Okay. There's still a couple things I'm fuzzy on here. But let's just go for it. Call this traverse. And traverse will take a node. And traverse will take a current strand, maybe. Let's call it strand. We'll say if node.left, then we traverse node.left pass our strand as is. And we come back up if no dot right. I haven't done a tree problem in forever. I do think it's cool how you go through them. Okay, and so we only record the node if we've been all the way down to the left or all the way down to the right. So we can push our node to the strand once we've been to both children. So something's not quite right there. I'm traversing correctly, but I'm not ever watching for that backtrack, which feels wrong. So let's take a look at this algorithm. So if I passed in traverse, and I passed in my root and an empty array, then what happens? So we pass in 1. It has a left, so we pass in, we go to 2. We pass in 4. Check. Okay, 4 has no left, 4 has no right. And so we push 4 to our strand. Okay, I don't need to see that stuff. Alright, so we push 4. We come back up to the 2. However, we don't record it yet. This is a problem. So it's like I need to track that was a backtrack. Okay, a plan is starting to percolate here. We track the size as we go along. So we start at 1. Our size is 0. We'll start size at 0. We'll do depth first or traversal. So we start at 1. It's got a left child of 2. We go there. It's got a left child of 4. We go there. We push 4 onto the strand. Okay. At that point, we can record. When we go back up to the 2, we can record a size of 1. A vertex count of 1. Maybe we'll call it edges. Okay, so now when we go to the right, we get a 5. When we come back up, what we need to do here is keep the max of left children or right children. In this case, it ends up being the same. So 1. So it doesn't even matter whether it's 4 or 5 because we don't have to keep our strand. No more strand counting. We'll just call it count. This is starting to look pretty good. I'm still fuzzy. Now I just need to determine when to count, basically increment or decrement. Diameter. It's amazing how much stuff in like computer science-y stuff that really just boils down to counting. Alright, so kind of walk through this again, and this time we'll actually code it. We start at 1, we go down, so we don't increment the count when we traverse to 2. we go down to 4. So at this point, when we are at the bottom, we are at a leaf node. We increment the diameter, or rather we increment the diameter, return the increment. So this isn't so much of a traverse as it is a count. Okay. So we got to the 4 and we said return 1. So we're back at the 2. And so when we have something like that, we basically need to say, we need to get the left count or right count and figure out which one's bigger. Just, okay. So what we'll do is we'll return whichever one is bigger, which will be do a ternary no dot left. Then we count the left hand side. I don't even need to pass the number. Otherwise, this is gonna get pretty. All right, negative infinity. No. 0. Oh, I don't know how to do that. We'll just say left count. Sorry, this is so scrambled. I don't really know how to talk about it, which probably means I don't understand the problem well enough to do it. And here I am coding anyway. Happy Saturday. All right, let's clear this stuff up and kind of look at it a little higher now. So what I'm doing is saying, oh, I can just do a math.max. So we can make that a one-liner. Okay, well, so let's walk through that algorithm. Oh, one last thing here. If node equals null, we'll just return 0. Okay, so that's our base case. So we've got a recursive count function. And what it does is it returns its left child count or its right child count, whichever one's greater. Okay, I feel pretty good about that. Hey Dave, how's it going? It's still dark here. A little too early to be coding maybe? Nah. So the problem I'm seeing here is that I'm never actually incrementing count, so it's just always going to be 0. I'm trying to figure out where I need to actually increment. So if my node equals 1, if null, all right, let's walk through and maybe we'll see where to put it. So here's the path I'll have taken. We'll start at the root, but we won't record it. Node is not null. Boop. I'm saying your left count equals, so we'll do this, left count is equal to node.left, and it does have a left, then count left. Okay, so we'll pop another frame on our stack here, and we'll go to 2. So now we're here. I say, do you have a left? Yes. So return. I'll put a little L on a right here, just to signify that we don't know what those answers are yet. Okay. Now we go down to 4. So you don't have a left. You don't have a right. So I almost want to say, is it just return 1 plus? That way I'm counting for me. Let's see here. You got any cool plans today, Dave? Any coding projects, or I don't know, any cool cartoons you're looking forward to watch? Oh, I grew up watching Saturday morning cartoons. I should get back to that. Alright, so 4, I can confidently say that you have 0 count for your left and 0 count for your right. So we're doing a math.max between 0 and 0, and then we're adding 1. And so up here at the 2, now when we return from our 4, we can confidently say, hey, your left is 1. And we travel down the right path. We're going to visit the 5. Our left is null, and our right is null. So left and right are for sure 0. So we come up here and we populate our right value. Awesome. Okay. That looks good. And now that we know our left and our right, we can return whatever the max is, left or right. It's going to be 1 plus 1. So now here, for 1, I can say the left is 2. And then the right side we have to go investigate. Dude, Stellaris is awesome too. I'm not for some Stellaris. But yeah, being stuck at home stinks. I haven't played Stellaris in a long time, but I'm a fan of 4X games. Are you in the gaming Slack? Oh yeah. Man, beer sounds good right about now. I could go for I want a beer right now, like a good breakfast ale. I'm not a big drinker, but I do like a nice stout. Alright, so here we're going to visit our 3. And then left is 1. And right is 1. Yeah. Sorry, and left is... what am I doing here? Let me start over. So now we're visiting 3. It has no left. It has no right. So here we can confidently say that the answer is going to be the math.max of 0 and 0 and 1. Heck yeah, man. All right, and so here, now we have everything we need to do to figure out the root. So in this case, we say what's bigger, 2 or 1? Answer's 2. And then we add 1 for the node itself, and we get 3, which is the right answer. So I think this is correct. I did want to check one other scenario, which is the one they call out here, where you may not have the root node. So we can imagine a tree. It's like 1. Yeah. So I only hang out in certain channels because, yeah, some of the stuff stresses me out too. But gaming is one of my favorites. It's like my wife never wants to watch The Office because she says it reminds her too much of work. Yeah, so there's some days when all I do is hang out in the gaming channel. But there is someone in the gaming channel that's mentioned Stellaris a few times. So I was wondering if he's the same person. If so, we've talked about playing before and just haven't got to it. Alright, so I'm going to start here. I'm just going to blow through it quicker this time. So 1, don't know. Okay. Now we visit 2, don't know. 4, don't know. 6, and 0, 0, which means now I can record 1 here, and then what I'm going to find is I'm going to go to 3, don't know. 4, don't know. And when I get to, sorry, 4 is actually 0, 0. And which means we ultimately return up to here of 0 to the left and 1 for the right. Okay. And then, so the 2 then is what I can figure out because I know both of its children. I forgot to record that. And so basically for 2, I say, hey, we got 1 and 1. So for, oh geez, this doesn't work. Because why doesn't that work? Maybe I went too fast here. I don't trust my results. Sorry, I think I went too fast. 2, I don't know. I've got a left and a right. 4, I've got a left and a right. No, sorry, geez. 4 has a left, but no right, so I can fill that in. 6 has no left, no right, which means our 4 gets a 1. And our 2 left-hand side is now my result plus 1, okay? So we go 3. That got me thinking about Stellaris. I always quit my Stellaris games when I get up to where you're like creating those subsidiary governments. I forget what it's called. That's like several hours in. I usually just play the beginning of the game for a couple hours and then start over. I play Endless Space a lot though. That's probably my favorite 4X right now. They got a new game coming out later too. Actually, now I have to look. The game is called Humanity. Games Together. Humankind. I'm hoping they like release a beta or something. Available in 2020. I don't know if there's like a release date. Yes. Ugh. Yeah, I'm doing it right. I don't know if I've ever played a game of Civ till the end either. I don't see anything about a release date. I've got it wishlisted, but yeah, I mean, it looks like a really nice Civ game. And I like all their other games, so I'm excited. Hopefully they release an alpha or early access or something soon, and I'll play the heck out of it. Okay. Oh man, I got distracted again. Alright, so 2 is 2. So now we're looking at the 3. We have no left children. We have unknown right. Now we're looking at the 4, which has no children. Which means that you return 1 plus 0. So 3. So back up at the 2. We now update this. So the 2 says math.max of 2 and 2 and adds 1. So we get a 3 here. And I'm worried about that. Alright, and then I shouldn't have called that 3. That's what threw me off last time. So now we add a 7, has 0 children. So we end up getting a 1 here. So in this case, my algorithm is going to take the math.max of 3 or 1 and add 1. So the final result is 4. The right answer is 1, 2, 3 and 4. So that is the right answer, but I'm not really comfortable with how I got there. As if we imagine an even bigger tree, like this, then we would have gotten a 5 there, and that's not the case, is it? 1, 2, 3, 4. No, that should have also been 4. Civ 6 was pretty good, I thought. I mean, they're all kind of different. They're all kind of the same. They had those other little city states in 6, which are kind of fun. I've been meaning to pick it up on Switch, but it never goes on sale. Man, Switch never goes on sale. Switch games? Not the good ones. So the trick is, how do I know that I don't get to compare these two? I think that I'm on the right track as far as like counting things up. It's just that I've got this condition where in this case I've counted up the max left and the max right. And what I'm doing is picking one or the other. So I'm saying each node either has to go left or right. And so basically my algorithm relies on you going through the route. Is that right? Geez, yeah, I don't know, man. This is throwing me off. This one is harder than I expected based on all the other problems. We finally bumped up to median. I'm just going to run through this example with my algorithm again. If I was an interview, I would probably be canned right now. So I go 2, I don't know anything about my left or right. 4, I do know that I have a right value of 0. 6, 0, 0. All right, so in this case, I return 1. I'm just going to do that. Okay. So now 4, we know 2 can now say confidently they've got 2. And we're going to open up a pathway to 3, which has no left, unknown right. 4, we get 0, 0. So you can return 1, which makes you 1, which returns 2. So I should do that too to be consistent. So here is the thing. This is going to return 4, 5. No. The way my algorithm works, I'm going to choose one path and add 1, which is going to be 3. But what I really wanted to do is say, hey, 1, 2, 3, 4. If I add these numbers together, then that's 4, and that's the biggest span we've seen so far. So basically, at any given point for any node, I can add these two numbers up to figure out what its span are for things going through it. And that's powerful. I think that's probably the secret. Yeah. Seriously though, who knows how to do a merge sort just off the top of their head? Like, nice. That is the right answer. It really is. Yeah, like I wish my day job consisted of solving stuff like this. That would be fun. All right, so the way my algorithm works is incorrect. That's true. Because here I'm going to return a 5, and that's not true. So I think the flaw here is I should not... Oh, no, you're right. Or sorry, you're right. I'm right. Because here I don't add these two together. I take them in and I add one. So this is what I'm returning, and this is this kind of other number that I can derive that I'm just going to hang on to for now. All right, and when I get up to the 1, now at this point I know that my left side is 3, and that's where the flaw is. Because I can't count that. That's not fair. Most problems I've related to this weird thing happened. Yeah, for real. Yeah, for real. Like I've been doing live streams on like Apache Beam stuff, and by far the thing that always takes up all the time is like going down some weird rabbit hole because the logger's not working, or some class isn't like doesn't work the way you expect or whatever. And so it's not ever like, you know, the loops and the trees that are tripping me up during the day job stuff. It's always like documentation and third parties and other stuff. Yeah, the mysteries. It's feel more like a mechanic or a detective than like a computer scientist. I do enjoy this stuff though. Alright, so down here we're going to get to 7. Let's go 0, 0. So it'll return a 1. And so here we'll return a 4, which, you know, looks like the right answer for this tree. But the problem is that when we get to 0, we're going to return a 4 and a 0, which is going to return a 5, which is, that's incorrect. So I don't know what to do about that. And don't know how to prevent that yet. One, two, three, 4. Yeah. If only that were more common, right? If only. Although here I have a problem with well-defined inputs or outputs, and I'm struggling with it. Like, how do I know? How do I keep track of the fact that I shouldn't count this one? Maybe I could say if I have a left value and a right value that are non-zero, then that means that I'm basically the root here. Then I should return only the left or the right plus 1, which is what I do. Yeah, so shouldn't this give the right answer? What am I doing wrong here? So say your left or your right plus 1. So this one gets the right answer. PC crashed. You running Windows? I'm also running Windows. Well, you didn't miss anything. Just me floundering. Thinking about Stellaris and why I'm not playing Stellaris instead of struggling with this stupid problem. 1, 2, 3. I don't know. I'm kind of back to thinking maybe this isn't wrong. Like, why did I write 4 here? Okay, I see. So on the 2, I return math.max of 2 plus 1, which is 3, which does go up in here. So at this point, with the 1, the answer is 3. I'm sorry, is 4, because I've got a span of 1, 2, 3, 4. So, I mean, this is 4. So when I come up to here, oh, it's not good. Time to upgrade, get a new video card. You don't have a choice, you got to. So this is where the problem is. Oh, cool. Are you with WSL? 1, 2, 3, 4. Man, this is driving me nuts. So this is not even the wrong answer. 1, 2, 3, 4. That answer is fine. And again, we can even add up the numbers and see that it adds up to 4. It's just that up here when we get to the root, I keep saying math.max of 4 or 0. And I'm adding 1. How do I know not to count that condition? You know, the only thing I can really think of is like, maybe it's okay to return 5. I just have to make sure that I only ever count the addition of these two numbers. So like here, 4 and 0 is still 4. So every time I add up these two numbers, you know, I can see that there are different ways to get that span 1, 2, 3, 4. So it does seem like adding these two numbers is always the right answer. Does that mean that maybe this algorithm is correct? I'm just thinking about it the wrong thing. Like maybe this number is returning the depth. But ultimately, I'm not looking for the depth. I'm not looking for the max depth. I'm looking for the biggest span. So I go through and count. And I'm returning 1 plus the max. Until it's done. But what I'm thinking about doing is basically like returning 2 things. One is like my current counter, and the other is like the potential max, which would be another math.max. Of my left count plus my right count. What's bigger, my left plus my right, or the current max? Geez, I don't know. I'm really struggling with this one today. This just feels hacky to me. It just feels wrong, you know? It feels wrong to me that I'm finding the max depth and then trying to make something out of it. I do think that adding these two numbers together does find the longest span. So let's do some renaming here. This diameter, that's not the diameter. In fact, I don't even need that. So all I ever do is return count. And then back to the idea of the strands. We'll call this max. We'll say if left count plus right count is greater than max, then we will uh-oh, my dog's up. Left count plus right count. So we're setting the max, but I don't like that we're not passing it into this. This doesn't make sense to me. So we just can't pass the current max. Is that right? Here, this is optimization. Let me just go old school here. This is taking me forever. I apologize. Hope you guys are having a good time. Hopefully this isn't too terribly frustrating. So we're going to take the strands and we're just going to, every time we return, we are going to add a strand. And the strands will just be I was just going to say the left plus the right, but we'll call this depth. No. Diameters. Okay, I think this is it. So diameters we're going to push left count plus right count. All right. Okay, so at the end of this, we can basically say we need to find the max of the item in the diameters, which for now I'm just going to cheat, do this the easiest way to type, and then we're going to refactor this, because if this works, I think we can make it much more efficient. So it's a greater than b, then 1, otherwise -1. All right, so let's see what kind of answer we get from here. Okay, unexpected number. Oh yes, all that gobbledygook. Okay, I got rid of the name count, didn't I? What am I doing? It's going to make it consistent. Count equals a function that does that stuff. Okay. I had some bad syntax there. Diameters dot push. What doesn't it like about push? This diameters is undefined on line 8. Diameters. Oh, I don't pass it. Okay, hey, we're getting close. Not a number. Because I need to return the first item. Actually, we need to return the last item. Here, I'm just going to do this for now. Just reverse that thing, return the first. Super hack. There we go. So there's the right answer. Wait, what's the custom use case look like? Oh, weird. Okay. So they pass me no, but the way they write it is kind of weird, so I don't know. Let's see if this works. No, okay. Output is undefined. How does undefined happen? Oh, because they passed me blank. So it's basically diameters dot length. Then we'll return that. Otherwise 0. Normally coding challenges like this don't make you worry about edge cases like that. Well, I guess it depends. Some definitely do, some definitely don't. Okay, try that submission again. Okay, so we have a correct algorithm. Yay! I think we can do much better on this this length though, this diameters, because I don't need to know the diameters. I can just keep track of this as we go along and just get rid of this whole block. All right, and we didn't talk about runtime, so we'll do that too. Runtime and space complexity. All right, so here for diameters, I don't need to pass the whole diameters. I could just pass the max that we've seen so far, I think. And then it's just awkward. I guess I just need a global. Ew. Max equals 0. Okay. So then I don't need to pass it. I don't need to pass this at all. Basically just say diameters dot push, not needed. Okay. Max equals left. Ugh. Const total equals left count plus right count, and max equals total greater than max, then max, then total, otherwise max. Oh, geez, which another way to say that, that's much slicker, is max equals math.max of either max or left plus right. So get that down to one-liner. Okay. So now we'll take whichever one's bigger there, and then we don't need to do anything with diameters. Diameters goes away, and now we can just return max. So we deleted a couple lines of code there. Okay, got the right answer. So if we submit, we should get the right answer again. Ah, that's funny. How on earth do we get 3 for a... Oh gosh, I bet it's resetting every time it calls the function. We need to reset max. Jeez. See, globals, man. Globals no good. No bueno. Any day now. All right, it's going to work. Yeah. All right, so let's take a look at the time and space complexity, and we made it through this harrowing problem together. Thank you. All right, so in terms of input size, our big O, let's look at that example again, is we will visit every item in the tree. So right now we are linear. We don't look at anything twice. So that's good. Nothing fancy. So yeah, I mean, that's good. Yeah, for real, man. That global, it was funny they got reused between the tests. I'm just, that could have been a nastier error. I don't really know how to do this without a global except for like creating some sort of weird kind of object. Dude, that's not harsh at all, man. I would not accept this. I've seen so many problems related to that. Felt dirty. So yeah, the runtime is good. I don't think that can be improved. I don't think there's any better way to do that. So I think we've got the optimum runtime. Of course, there's always room for optimizations there and the actual time it takes to run stuff, but I think that's good. Now, where this is not a good solution is that we are a recursive, a recursive algorithm, which are usually bad in terms of memory. So like, remember when I was doing all the, whatever, kind of working through the algorithm, that represents the size of the stack as each function is called, and increases the size of the memory I've allocated at any given time. And in worst case scenario, memory footprint is going to be the entire size of the tree. So like if you imagine a straight line, we'll visit each node, we'll have one frame on the stack for each node, allocating at least 2 variables. Those are constant though, so we're doing 2 variables times potentially n, so it just falls down to n. So the memory complexity, if we swap this to an iterative algorithm, we could get that down to constant. So if I were in an interview, I would say, we've got the best runtime. I feel good about that. However, our memory usage is really bad compared to an iterative approach. So if we just did the DFS style traversal, which is totally possible, it's just awkward. If we coded that, then we could get the memory complexity down to 1. So when we look at the answers here in a minute, and look at the distribution, we should see that there are some answers that are grossly better on memory, but not too much better on speed. So let's see here. So like we expected on runtime, pretty fast. We're in the faster half of algorithms, so that's good. Memory distribution, I don't see my line here, so I'm not really sure how to interpret that, but how much you want to bet this one is an iterative solution? Okay. So those are just comments. All right, here's the actual thing. And yeah, so no recursion. It just iterates through. And this actually doesn't look too bad. Wait, what's this? So it is recursive. Okay, so I'm surprised to see that there's a recursive solution that's lower in memory. I really expected to see an iterative answer here. So that's weird. That's that's QIT running index process. Okay, well, it does make me think if we went the extra mile and made this iterative, that we could be maybe even beat that one. So I think we could do better. But I'm content to let this problem go. It took me way too long to get there, so thanks for hanging out. That's how it goes sometimes. I'm curious to see if that one's a medium. How do I just... Maybe I could... I want to see like the normal page for it, not the challenge page for it. So all these problems are previous LeetCode problems. All right, here we are. So this one's still counted as easy. It definitely wasn't easy for me though. I kind of want to look at the solutions and see if anyone talks about iterative. Yeah, people are saying recursion beats 100%. I wonder if it's talking about runtime or yeah, I don't want to see O of n. I want to see O of 1 on space. I think we can do it. This is going to bother me. It's like, is there something I'm not understanding why this can't be iterative? This is all basically what we did, just... Man, I don't know. I don't know, man. I think I've tainted your mind with my dirty solution. But this looks really similar to the ones that other people were doing. Go ahead and submit one more time to see the results here. Okay. So I'm not good on the memory. And runtime is fine. But yeah, this is going to bother me. But it's not going to bother me enough to do it. So I'm going to take a break and come back and do some QIT project work. And I think I'm going to do that on Twitch instead of YouTube. I don't know. I'm still kind of thinking about that. And also later today, I'd like to do some more work on Beam. So we've got some data flowing there. We're actually pulling that from Kafka now. So I'm going to try and get that to an end-to-end solution and then probably start all over with a new project with Beam that'll go much faster, that I'll actually try to do something different with like real data, solving some sort of problem in the real world. And yeah, so that'll be cool. Hopefully we'll be getting there both places today. All right, for now, I'm going to go get some more coffee. Thanks for hanging out. And yeah, rock and roll.